right, so today we're going to look at the final topic that we are going to cover about matrices, and this is inverses of matrices. It's going to tie in a lot of what we did yesterday, so that'll give us some extra practice at doing that whole row echelon form. Okay, so let's go ahead and jump right in. All right, now before we talk about inverses, we need to talk about identities. And I know this isn't in your notes, you're just going to follow along here. And okay, so let's go back to algebra 1. And this is something like literally pre-algebra, algebra 1. Let's see what you remember from then. All right, it says here that the additive identity is the value that you can add to get the identical same thing. That's why it's an identity. What can you add that won't change your value? Okay, well, obviously that's going to be a 0, right? Let's say that I have the number 5. All right, and I can add 0 to it, I still get 5. And it doesn't even matter the order, I could do 0 plus 5, and I still get 5. Okay, so 0 is the additive identity. Okay, let's talk about the multiplicative identity. That's going to be the identity or the value that you can multiply by and get the identical same thing. So what would the multiplicative identity be? Okay, well, that's got to be a 1. I can take a 5 times 1, and I still get the identical same value. And again, the order I do it doesn't matter. I still get the identical same thing. So this idea of the identity, getting the identical same thing, those are algebra concepts, but they do translate over to matrices as well. If you think about what would an identity, and I'm going to start with an additive identity matrix. What do you suppose if I had some, and I don't know that you don't even have this slide, so it doesn't matter. If you had some matrix, and I'm just going to call it a 1, 2, 3, 4, let's say, what matrix could I add to it that would still get me the exact same matrix 1, 2, 3, 4? Okay, well, first of all, to add matrices, they have to be the same dimension, so it's going to be another 2 by 2, and you just add corresponding parts, so it would have to just be a bunch of zeros in here. Okay, that's the additive identity matrix. But because there's not really much going on there, we don't really talk about that so much. So we are going to focus on the multiplicative identity, and that is a little bit fancier than what I just did there, because how we multiply matrices is a little bit more challenging. Remember how you do the whole this row by this column kind of thing when you're multiplying matrices? So we have to think about that, and that's going to make the identity matrix for multiplication be trickier. So for the identity matrix, and we label the identity matrix an I for obvious reasons, okay, for it to be the identity matrix, you've got to be able to take some matrix A, I'm just call it A, and be able to multiply by I and have it not matter and still end up back at the original matrix A. And it should work both directions, like I was doing earlier. It doesn't matter which one you put in front, you should still end up with that same matrix A. But that actually creates a little bit of a problem, because if I'm going to take matrix A, let's just pretend it's a 2 by 2 or a 2 by 3, let's say, and I'm going to multiply it by this identity matrix. Well, the identity matrix is going to then have to be a 3 by something, because remember, these have to match in order to be able to multiply. But the problem is that whatever I choose to do, I'm supposed to end up back at my matrix A, so I've got to end up back at a 2 by 3. So maybe this, would that work? So this would be the 3 and 3 would allow me to multiply, but then I would end up with a 2 by 3, which is what I'd want to have. Oh, look at that, just fixed it for me. Okay, I didn't know it could do that. Here's the problem, though, is if that's the case, and let me kind of sneak some parentheses in here, these are my two things, can I swap that around? could I do a 3 by 3, which is the identity matrix, and multiply it by the 2 by 3? So we talked about this the other day. I'm trying to refresh your memory. The only way that you can get these to multiply both directions like this is if your matrices are square matrices. So I am not going to be doing that. So if you wrote that, erase that. We do not want that. They have to be a 2 by 2, a 3 by 3, a 4 by 4. That's the only way you're going to be allowed to multiply them both ways. So we're going to stick with 2 by 2s and 3 by 3s. We're not going to get any bigger than that. So these are the identity matrices we will be using. This is a 2 by 2. This is a 3 by 3. Now look at what I've got. I've got zeros and ones. And where those ones are located in that matrix is important. You want the ones to fall along the diagonal. Everything else is a 0. All right, let's look at this example I have. It says, given the 3 by 3 identity, give the 3 by 3 identity matrix I3. So this means identity. This means it's a 3 by 3. Show that matrix A times that identity matrix would still get us matrix A. All right, so here's matrix A. It's a square matrix. It's a 3 by 3. Next to it, I'm going to put the identity matrix. That has the ones down the main diagonal. And then this is a good refresher of how is it that we multiply? Remember, you take first row times the first column. All right, I've got a 3 by 3 times another 3 by 3. I'm going to end up with a 3 by 3. And to find the first row, first column slot, I take the first row times the first column. Well, I'm going to take a -2 times a 1, but the other two values are going to get multiplied by 0. So I'm just going to get a -2 times a 1. So that's -2. Now I'm going to work on first row, second column. So first row, second column. You can see that the zeros are going to cancel out these two terms, and the only term that's going to get salvaged is the 4 times 1, which is a 4. Now I'm going to take this, probably didn't need to have an extra 0 in there, but it's going to get multiplied, or this row times this column. So that's going to be times 0, that's going to be times 0, and then that 0. So I'm going to end up with a 0. Okay, then we would go to the second row, first column. So second row, first column, look at what you're going to salvage. Just that first value. The other two are going to get multiplied by 0. Okay, so what happens is because of the placement of those ones, that salvages the one value that I want each time. And so you can see that my first row matched my first row over here, and then I got a 3. And what do you suppose the rest of it's going to be? It's all going to match. And so that means that I got the identical same matrix. So that's what is making this be the multiplicative identity. So these are multiplicative identities. We're only talking about multiplicative, so forget the additive stuff at this point, and we'll focus on the multiplication. All right, so now I'm going to move on to inverses, and we're going to start off back at Algebra 1. I know you don't have this slide, you're just following along here. So the additive inverse is the number that you can add to a given value and end up getting the additive identity. That's what an inverse is. It's what you can do to get to the identity. So the additive inverse would be, in this case, I would have a -5. If I add these together, I get 0, and 0 is the additive identity. And the order doesn't matter. I could do a -5 on the front plus 5. I still end up at the additive identity of 0. Okay, now let's talk multiplicative. The multiplicative inverse is the number that you can multiply by to by a value by and get the multiplicative identity. So I'm trying to figure out what can I take 5 times and get 1? Well, it would have to be a 1/5. 5 times 1/5 would get me a 1. And the order doesn't matter. It works both ways. Okay, so that's what I'm going to focus on with my matrix inverse. Again, we're going to stick with the multiplication, not the addition, but I'm trying to figure out if I am given some matrix here, what's the matrix I can multiply by to get the identity matrix. That's the one with the ones and the zeros. So that's what I'm focused on, is how would I figure out what this inverse matrix would be? Okay, so this is what we just talked about, but now you have this slide so we can look at it. The inverse matrix is the matrix that you can multiply by and end up with the identity matrix. So it's going to look like this, but it could also go the other way. So again, only going to work on square matrices. Only if it doesn't have a square matrix, it doesn't have an inverse. So this says check if the matrices are inverses. So what we're going to do is we're going to use that little rule. If I take A times the inverse, do I end up at the identity matrix? Let's give it a shot. So here's A. And here's the one I'm checking to see if it's the inverse. And now we take first row, first column. Remember, it's a 2 by 2 times a 2 by 2. I'm going to go down instead of across because I have more space here. I'm going to end up with another 2 by 2. So first row, first column. That's going to be a -1 and a +2. First row, second column. That's a 2 and a -1. Or I'm sorry, and a -2. That's 0. Then I have this row, this column. So that's going to be a -1 and a +1. That gets me a 0. And now I'm going to do the bottom row, last column. That's a 2 and a -1. And I got a 1. Okay, it worked. That is the identity matrix right there. Okay, now I'm going to have you practice. Does it work the other way, though? So you set it up and put the inverse in front. Multiply it. They're both 2 by 2, so it's possible to multiply. And you will end up with another 2 by 2. I'm going to pause, or you're going to pause the video for just a second and go do your multiplication. So pause and then come back when you're done. All right, hopefully you got the identity matrix because it did work. If you didn't, check your signs, make sure you didn't make any silly mistakes. So we can check if they're inverses if you multiply them and you get the identity both ways. Just a few rules about this, and just to kind of reiterate some of the things I've already said there. So A is going to be a n by n matrix. So notice n by n. Rows and columns are going to be the same. So only square matrices even have inverses that we're going to even be looking for. Now, just as a side note, not all square matrices have an inverse. Now, I'm not going to probably mess with getting into all of that, but only square matrices would even work to do this with. And if it truly is going to be an inverse, then you should be able to multiply this direction and get your identity matrix, but you should also be able to multiply the other direction and get that identity matrix. And just a little bit with notation, this little -1, just like when we talk about inverse functions, that little -1 superscript is going to be indicating that it's the inverse, and we read it A inverse when you see this, A inverse. Now, with all of that, the thing that's kind of that I haven't really drawn attention to yet, but it's kind of an important thing, is I've always given you what the inverse is. Really, what our goal today is mostly going to be to, how do you find that inverse? Okay, so for this multiplication to work both ways and to end up with an I, we have a little strategy we have to find the inverse. The first thing you're going to do is you're going to set up an augmented matrix. An augmented matrix is what we had yesterday. And the augmented matrix, and actually, it's right down here. I don't know why I have it up there also. This is going to be your augmented matrix. You're going to take the A matrix that is given to you. You draw in this line here, and then you're going to put the identity matrix. So this is going to be kind of a long one because this could be like a 3x3 and another 3x3. So different sized matrices that we'll deal with. Then what your goal is to do all that row echelon work that we did yesterday and convert this matrix into this matrix. If you can sit there and do all your rules that we've been doing to take this A matrix and turn it into an identity matrix, which is really what we've been doing, right? To solve the system, that's what we did. It ended up being a 1, 0, 0, 0, 1, 0, 0, 0, 1. It was the identity matrix. We just didn't call it that. So we're going to do all those same rules, get the identity matrix on the left, and what you have left over on the right side, that's the inverse matrix. Let's try one. Once you realize that this is what we're doing, that we're following this little rule here, then all we're doing is kind of a repeat from yesterday. But the numbers are going to be a little nicer today, I promise. Okie doke. So here we go. They're going to give me a matrix. Here it is. Remember, it's got to be a square matrix. We're going to do a 3x3 because we're feeling good. 3x3 is on the left, identity matrix on the right. All right, I am going to write this really little because all of that has to fit in this matrix. Now, I have chosen here today to go ahead and just give you some blanket matrices here. You've got all the rules. Just because I don't want to restrict you too much, now that you know how this works, if you have your own strategy, maybe you want to swap some rows or divide a row by something, I've given you an extra matrix in here to allow to do that. Now, so you may or may not use all of the matrices. I know that we definitely are not going to be using all of the lines for the rules. We won't need them all. So here I go. First thing, let's write the matrix on the left. Maybe watch what I'm doing here so you can plan ahead on your spacing. It's going to look like this on the left. And then you draw that bar. This is your augmented matrix. And then you're going to put the identity matrix that looks like this. The next step is to start working on getting this matrix, or getting this side, I guess, to look like this. So remember how we do that? We work on the first column and we're working on zeros. I don't care about the ones yet. Just work on the zeros. So I need a rule for row 2 and I need a rule for, oops, I should really be looking here. I need a rule for row 2 and a rule for row 3 to get these two to turn into zeros. I'm not going to be using this first one. So since I'm not changing the first row, if I want to go ahead and fill in the first row, I can certainly do that. Now, the second row. We may not all agree on what the rules are. That's okay. I guess I'm just going to make them up because I can't hear what you're saying. So here we go. As far as coming up with a rule for row 2 to turn this into a 0, I think the thing that jumps out at me is probably row 1. I'm going to do a row 1 minus row 2. That's going to be my rule. So then I get 1 minus 1 is 0. Negative 1 minus 0. 0 minus negative 1. And then I keep on going. I just keep on going with the same thing. Row 1 minus row 2. So 1 minus 0, 0 minus 1, and 0 minus 0. Now let's look at a rule for row 3. I want to turn this 6 into a 0. So I could group it with either one. I kind of like the 0 sitting there. That might be easy. So I think I'm going to group it with row 2. So I am going to make row 2 be a negative 6. So negative 6 row 2, add it to row 3. Just a quick reminder that when you're picking these rules, you can never choose the same 2 rows for both rules. So I've got a 1 and a 2 here, and a 2 and a 3. So those are different. I'm going to be good. Here we go. Negative 6 times row 2 plus row 3. That's going to be a 0. Then I'm going to have a negative 6 times 0 add it to row 2. Negative 6 times negative 1, so that's a 6 plus a negative 3. Then I keep on going. This is going to be 0 plus 0. This is going to be negative 6 plus 0. And then the last one is going to be a 0 plus a 1. There we go. Now, something to note here. I decided, like, even though this all went up here, and typically I wouldn't really want that guy right there to be a 0. But so you might have chosen, and this is why I gave you extra matrices, you might have chosen to rearrange. Maybe you would want to put this one up here and put this one down here. You might have swapped row 1 and 2. I didn't even mention that. I should have, because that certainly would be a good option. Sometimes I just jump in and I just go through the motions. I don't know if that's smart or not. I could definitely do some shortcuts if I took the time to do that rearranging. I probably should have, but I'm this deep. I'm going to keep going. I have now, I'm working on the second column, and I want the top and the bottom to be zeros. So that means I want this and this to be zeros. So I'm going to have a rule here and here. I'm not going to have a rule in row 2. I'm not going to change anything in row 2. So let's work on row 1. If I want to take this and I want to turn it into a 0, I could group it with either one of these, though I feel like this one might be easier. So I'm going to do, let's see how I want to write this. I'm going to do negative row 2, and then I'm going to add it to row 1. It's going to look like that. So that would be negative 0 plus 1. Then I'm going to have a positive 1 plus a negative 1. There's that 0 I wanted. Then I want negative 1 plus 0. Negative 1 plus 1. Positive 1 plus 0. And 0 plus 0. All right, next thing I'm going to do is I'm going to turn this negative 2 into a 0. I don't really have options. I sometimes ask, what rule do you want to make? But I'm going to tell you what, you don't really have options here. When you get this far in and you've already got some zeros created, you have to be careful that you don't lose those zeros. So if I decide to write a rule here that includes row 1, this 1 right here is going to mess up the 0 I already have. So right now, and for now on, I'm kind of restricted. I've got to only use rows that have zeros at least where my existing zeros are. So in row 3, since I have a 0 here, I can only group it with other rows that also have a 0 there. So row 2, I cannot group it with row 1. So I'm going to do something with row 2 and 3. I want this to be a 0, so I think I'm going to take negative 2 times row 2. Negative 2, row 2, add it to row 3. All right, I'm going to end up with a 0. Then I'm going to have a positive 2 plus a negative 2. Then I'm going to have negative 2 plus 3. Negative 2, negative 2 plus 0. That's going to be a positive 2 plus negative 6. And then I'm going to have a 0 plus a 1. Okay, this is looking good. I've got my zeros and my 1 here. All I've got left is this last column. And in the last column, I want these two to be zeros. So that means I'm going to be writing a rule here, writing a rule here. I'm done with this row. I'm so done, I don't even have to mess with dividing by anything. It's already a 1. So I'm getting super lucky here. 0, 0, 1, negative 2, negative 4, 1. That's not going to change. Now let's come up with a rule. And remember what I said, if I'm going to come up with a rule to try to turn this into a 0, I can only combine this row with another row that would have a 0 in this spot. It's going to be row 3. And in fact, I'm going to get stuck on this one, only be able to work with row 3 as well. On your last matrix, you will always be grouping with row 3. All right, to turn this one into a 0, I'm just going to add the row 3. So I'm going to write it like this, row 3 plus row 1. Just adding those two rows together. I can do that very quickly. Got it. Okay, I love that rule. That's a fast one. Okay, now I'm going to work on getting this to be a 0. And again, I can only group it with row 3. So I'm going to say row 3 minus row 2. Right, this is going to be another one that's pretty quick and easy. Row 3 minus row 2. 0 minus 0, 0 minus negative 1, 1 minus 1, negative 2 minus 1, negative 4 minus negative 1, and 1 minus 0. And we've got it. All right, looky what I have. I've got the identity matrix. That was my goal. I've got this done right here. So if this is the identity matrix, that means this right here is the inverse matrix. I gave us an extra one just in case we needed it. Would have been good to, if I had chosen at the very beginning to swap a couple of rows, which again, totally great idea if you did it. But I didn't, so I didn't need that last matrix. And so my final answer to write A inverse as a nice 3 by 3 matrix. All right, and we are done. So this, you can see, is just mostly just the same thing we did yesterday. Now, I said that the numbers are going to be nicer. Well, let me forewarn you. Again, one of the reasons I like what we do here with this row echelon is you never have to battle fractions. The only time that you're going to get a fraction is if one of these ends up being something other than 1. So let's pretend this ended up being a 5. If this was a 5, then I would take everything in this row and divide by 5. Now, don't do it, but I'm going to show you what that would look like. If that was a 5 and I had to divide the entire row by 5, this row right here would not be near as pretty. It would be negative 2/5, negative 4/5, and 1/5. And there's a reason I'm telling you this is because it happens on your homework. I pretty quickly on your homework where you're going to end up, your final result will have fractions, and that's okay. You're never having to do anything with them except just write them. You can write fractions. It's okay. It's going to be totally fine. All right. I think that's all I've got for us. I think you're going to do great. Jump in there and get started.